Hello, welcome back to Unit 5, Quadratic Expressions and Equations. In this, our fifth unit in our Algebra 2 course, we're going to focus on the basic algebra involved with expressions that have an x squared in it. So in this lesson, we'll just look at simplifying quadratic expressions. While quadratic expressions can come in many varieties, they all have to have an x squared as their highest degree term. Here, here, and here. More generally, we're going to say that an expression of one variable is quadratic if it's of the form ax squared plus bx plus c, where a doesn't equal 0. If I set a to 0 and remove this x squared term, it would become linear. And again, it just needs to be able to be put in that form. So you can see it could look in different orders, but as long as I could rearrange things and put it in that form, it's a quadratic expression. So let's start by simplifying. I'm simply going to combine the like terms of these expressions. And I've got 6x squared minus 3x and minus 3. On the next one, I have 7x squared minus 21x minus 18 plus 2x. I'll combine like terms. 7x squared minus 19x minus 18. All right, on this next problem, we're going to multiply it by 2x. And remember that x times x is x squared, because that's what x squared means. So 2x times x is 2x squared. Then 2x times 7 makes this a minus 14x. And then we have plus 3. All right, let's simplify the following expressions here. I have some problems for you to do, so pause the video and try these. Okay, welcome back. Let's try it now. We're going to have, see here, a negative 3. No, I'm sorry about that. It's just a negative x squared. And then we have, let's see here, 1x term, so minus x, and then plus 8. All right, on this one here, I have a negative 3x squared plus 12x. Then we have plus 2 minus x. So negative 3x squared plus 11x plus 2. All right, let's take a look at this one. X times 4x is 4x squared, and then x times 1 is minus x, and then plus 2. All right, on this one, I've got a negative 7x plus x squared plus 3x. I'll just simply combine like terms and get x squared minus 4x. All right, the product of two binomials, these are binomials, bi meaning two, right? So a binomial has got two of these terms here. The product of two binomials can be found with the famous mnemonic FOIL. Stands for first, outer, inner, last. And you can see how I kind of trace that out here. You can see that the first here I'm indicating with green, the first terms in each factor. So 3x times 2x is 6x squared, and then the outer would be the 3x and the 7 is 21x, and the inner is 5 times 2x, and the last is 5 times 7. But this is, this is basically just double distributing. I just think of it as like I'm distributing the 3x to both terms, then I distribute the 5 to both terms. All right, let's take a look at some examples where we have to FOIL. All right, I have x minus 1 times x plus 3. That would be x squared for the first one. Then x times 3 for the next one, so plus 3x. Then minus 1x and minus 3. Combining like terms gives me x squared plus 2x minus 3. All right, let's try the next one. We have 2x times x is a 2x squared. Then I get 2x times 4, so plus 8x. Now I use the 1, making this plus x and plus 4. So we have 2x squared plus 9x plus 4. All right, now in this situation, I do have a 4 out in front. I could distribute the 4 to the x and the plus 1. I could even distribute the 4 to the x minus 2. I just can't do it to both. What I would like to do is I would like to just leave that 4 out on the outside. I'm going to distribute here, and that'll be x squared, then minus 2x, but plus 1x. So minus an x, and then minus 2. And now I'll multiply through by the 4, getting 4x squared minus 4x minus 8. Okay, let's take a break and have you do a few, all right? So let's try these problems. All right, let's see how you did. We have 2x squared minus 6x. Then down here we have to FOIL. 3x times 2x is 6x squared plus 30x for the outer, minus 2x for the inner, and then minus 5 for the last. So that's 6x squared plus 28x minus 5. And then down here, 5 times 3 is 15. 5 times x is 5x. Negative 2 times 3 is a negative 6x. And then a negative 2x times x is a negative 2x squared. So we have negative 2x squared minus x and plus 15. All right, let's take a look at example 1.3. We have x plus 3 squared. So we have to square this binomial. So don't think we can distribute the squared. We can't do that. That is not allowed. You cannot put a squared over addition. So we're just going to write it out like this. X plus 3 times x plus 3. When I square, I get x times x is x squared. X times 3 is plus 3x. Then 3 times x is plus 3x. And then 3 times 3 is plus 9. And I'll combine like terms. X squared plus 6x plus 9. So you can see that squaring a binomial, that's two terms, equals a trinomial. Let's try another one. X minus 4 squared. Oh, just rewrote it exactly what it was. X minus 4 times x minus 4. X times x is x squared. Then I get x times a negative 4 is a negative 4x. Then another negative 4x. And then a negative 4 times a negative 4 is a plus 16. So notice that when I square x minus 4, I end up with a plus at the end. And then there's two of these terms that are the same in the middle, giving me x squared minus 8x plus 16. All right, now let's look at this one. I have 2x minus 3 times 2x minus 3. All right, 2x times 2x is 4x squared. 2x times minus 3 is minus 6x. Then a negative 3 times 2 is a minus 6x. Then a negative 3 times a negative 3 is a plus 9. So that makes this 4x squared minus 12x plus 9. Okay, so what is all this showing us? Well, it's showing us a pattern. And that pattern is that we always end up with two of these terms in the middle. Do you see that? You see these, we got the double minus 6, 2x times a negative 3. Then we had, here we had double minus 4x. We had a double plus 3x. And so we can see that in the pattern, that if you have a plus b squared, if you FOIL that out, you'll get a square in the a and a square on the b at the front and end. And in the middle, you get this 2ab. So when you square a binomial, do not forget the 2ab. But let's try and use the formula to do this more efficiently. So 2x plus 1 squared. We know that this is the a and this is the b. So we square the a and you get 4x squared. Then multiply a and b together and double it. So 2x times 1 times 2 is 4x, and then square the b. All right, let's do the next one. Square the first term, 49. Multiply the 2 together and double it. Negative 14y, and then square the last term. Remember, your first and last term will always be positive. The middle term takes the sign in the middle here. All right, your turn. Again, I encourage you to use the formula that a plus b squared is equal to a squared plus 2ab plus b squared, because we need that formula down pat. All right, let's see what you did. X minus 3 squared. That would be x squared. And then multiply these two together and double them, minus 4x, and then square that. I'll do the next one. Square this. Multiply the two together and double it, and then square that. All right, square this. Multiply the two together and double it, and then square this. All right, on this one here, we're going to square the first term, multiply the two together and double it, and square the last term. All right, let's take a look at these. We're going to multiply these expressions. All right, we have x minus 3 times x plus 3. X times x is x squared. Then x times plus 3 is a plus 3x. And then minus 3 times x is a minus 3x. Then negative 3 times 3 is a minus 9. But you'll notice that in the middle, I have these opposite things that cancel out. So it's left with just x squared minus 9. So 2x times 2x is 4x squared. 2x times plus 5 is plus 10x. Negative 5 times 2x is a negative 10x. And negative 5 times 5 is a negative 25. And then again, these things go away in the middle because of the different signs. So it's almost like the opposite of when you square a binomial. Instead of doubling, they cancel each other out. All right, let's take a look at this one. 5 times 5 is 25. Minus 5x when you do here. And then plus 5x for the inner. And then the last. So we end up with 25 minus x squared. So notice that each time we end up with two terms and their perfect squares subtracted. So we call these things, when they have different sign in the middle, we call them conjugates. A plus b, a minus b. And they always work out to a squared minus b squared. And this is commonly called the difference of two squares pattern. And that's going to be a really important pattern for us. All right, so go ahead and multiply. Let's do some practice problems. I want you to go ahead and do all of these. So A through E. Pause the video and go ahead and do them. All right, let's see how you did. X times x is x squared. Then minus x plus x minus 1. Well, actually, I don't want you doing that anymore, do I? I want you using your pattern. So do you see that this is a difference of two squares? Since it's a difference of two squares, it's just going to be x squared minus 1. And this is a difference of two squares because they're different signs. So it's going to be 4x squared minus 9. This next one is a difference of two squares. It's x squared minus 16. Then here we have x minus 10 squared. This is our perfect square, perfect square trinomial pattern. So when we square a binomial, we square this first term, multiply the two together and double it, and then square the last term. And we can see that as well here. Square the first term, multiply the two together and double it. So it's not 3ab, but 6ab. And then plus 9b squared. Make sure you square both the 3 and the b. Okay, well, that's it for this lesson. I'll see you in the next one.